Little did we know last year when Art was speaking to us here at a session just like this that we had a budding politician on our hands, let alone one who revels in rattling cages. So this should be very interesting. So tomorrow night, after you fly home, if you fly home tomorrow night, you can check out the results. If you are staying through tomorrow evening, you can retire to your hotel room, turn on MSNBC, or some other more appropriate cable television channel of your choice, and catch the results. You know, every now and then when I'm out giving a talk on global warming, when I do give these talks, more often than not, the first question I hear afterwards is, well, Mr. Taylor, you make some pretty persuasive points, but what if you're wrong? Now, there are many ways that I can and indeed have responded to such a question. I can and have mentioned the Copenhagen Consensus, where we have some of the world's most preeminent economists that have assumed that the United Nations IPCC projections are correct, and nevertheless determined that global warming is a poor investment of our economic resources, that we can spend our money and get much better results elsewhere. I can and have mentioned the fact that, okay, 100 years from now, we are quite unlikely to be basing our economy on carbon sources. I can mention that if I am wrong, we will certainly have many decades advance notice, and we can certainly take steps along the way as well. But the more I think about it, the more I think I've settled on this response. And my response from now on is going to be, well, I know I'm right. And when inevitably the questioner says, well, Mr. Taylor, how do you know you're right? I'll simply say, I know I'm right because Richard Lindzen agrees with me. Our keynote speaker is one of the true giants of modern science, and I believe that long after we're gone, he will still be remembered as such. Dr. Richard Lindzen has authored landmark research on ozone photochemistry, atmospheric tides, the quasi-biennial oscillation, and the superrotation of Venus. That each of these have advanced scientific knowledge in their fields to an unprecedented level of understanding. Dr. Lindzen also was the first to grasp and explain how the behavior of tropical cirrus clouds reduces the warming effects of atmospheric carbon dioxide. He is a member of more scientific organizations than I have time to recite. He has been a lead author for the United Nations Intergovernmental Panel on Climate Change and a co-author of the National Academy of Sciences 2001 report, Climate Change Science, an Analysis of Some Key Questions. Among his many impressive professional accomplishments and positions that he's held, he has been a researcher for the National Center for Atmospheric Research. He's been a professor at Harvard University. He is currently the Alfred P. Sloan Professor of Meteorology at the Massachusetts Institute of Technology. It is my extreme pleasure to introduce to you our keynote speaker, Dr. Richard Lindzen.
On that note of hyperbole, I suppose we can start. As for the first slide, if possible. After Art Robinson's talk and several others, this will be a bit dull, but I think it's essential. How do I control this, by the way? This here? Okay. I'm going to just try and go through the science and the meta-science, which may be more important. Let me begin with two statements that, in fact, should not be controversial. They're agreed on by the Intergovernmental Panel on Climate Change, and nevertheless, I think we should be aware of these statements. The first one is that if you doubled carbon dioxide, that by itself will only contribute about 1 degree centigrade to greenhouse warming. All current models project more warming because within the models there are positive feedbacks from water vapor and clouds. And these feedbacks are considered by the IPCC to be uncertain. Okay. Anytime you hear that all that is involved is basic physics, the greenhouse effect has been known for centuries, you're conflating something, and we'll come back to that. You're conflating the trivial with the alarming. They're not the same. The second point is, if one assumes all warming over the past century is due to anthropogenic greenhouse forcing, then the derived sensitivity of the climate to a doubling of CO2 is, less than 1C, or on the order of what the greenhouse effect would do by itself. And the question then arises, how is it that current models that predict more warming than this are nonetheless claimed to be capable of matching the past data? And the answer is, and the IPCC is pretty upfront about it, they have canceled the excess warming by a fudge factor. The fudge factor is called aerosols, but as was pointed out, each model chooses a different value to bring its model into agreement. So it's an adjustable factor. Now, how shall I put it? Given the above, the notion that we're dealing with settled science, I think should be offensive to any sentient individual. Of course, this isn't emphasized by the IPCC, but one of the peculiarities of the IPCC is it actually has this information in its documents. Now, another notion that is perhaps peculiar but commonly stated is that models are our only tool given the complexity. And, even if this were true, it would only be meaningful if the models were objective and not arbitrarily tuned or adjusted. But it's not true. Models are not our only tool. They're useful. I think, the notion of, modeling versus not modeling and so on is a red herring. Models have their use. And one of the things that I find very useful about models is you, in principle, have control of them. And so when they behave a certain way, you can find out why the models behaved the way they did. And that then tells you what processes in the models have caused it to do what it's done. And these processes can be independently assessed by both observations and basic theory. And this has been done, and the results suggest that all models are exaggerating warming. If we have time, I'll show some of these studies, and otherwise I'll just sketch them. Now, even without this very basic breakdown of the case for global warming alarm, there are any number of reasons why an intelligent observer should be suspicious of the presentation of alarm. Certain things that occur in the discourse are just immediately red flags. The claim of incontrovertibility. That has nothing to do with science. Arguing from authority in lieu of scientific reasoning and data, or even elementary logic. The use of the term global warming without either a definition or a quantification, as though somehow it was an obvious parameter. We'll come back to that. The identification of complex phenomena, and that includes the tornadoes and other things that were discussed earlier, things that have multiple causes, and associating them with global warming, and indeed claiming their existence itself is proof of global warming. And then the very and here Gore is phenomenally guilty, the conflation of the existence of climate change at all with anthropogenic climate change. Now, here are some salient points. By definition, nothing in science is incontrovertible. And that's true down the line. I mean, think to yourself what issues you've been told are incontrovertible. And you'll find there are quite a few. Essentially, society has gotten away with this quite a few times. But certainly in a primitive and complex field such as climate, incontrovertibility belongs to religion, and it's referred to as dogma. It's not about science. The value of authority in a primitive and politicized field is also of dubious value, and that applies to me as well as to anyone else. You have to deal with the science itself. And that's painful to a lot of people. I think the reason you get away with authority is most people don't want to deal with science. But the late Aaron Wildavsky made the point that's really the citizen's only alternative. With respect to the last item, the situation may not be as difficult as it sounds. And, here's one way you can handle it. I don't imagine anyone can read this, but this is a letter that appeared a couple of weeks ago in Science magazine. It was signed by 250 members of the National Academy of Science. Most of the signers had no background in climate science. Many were the usual suspect, Paul Ehrlich, Steve Schneider, George Woodwell, etc. But a few were indeed active contributors to the science. Now let's look at some of their assertions. Here are two of several that were listed. In this letter, they said natural causes always play a role in changing Earth's climate, but are now being overwhelmed by human-induced changes. The other statement is warming the planet will cause many other climatic patterns to change at speeds unprecedented in modern times, including increasing rates of sea level rise and alterations in the hydrological cycle. Okay. Now, what are you going to do with this? Here you have 10% of the National Academy signing this. That's authoritative. But, for instance, one of the signers was Carl Wunsch. You can go to the journals and see what he says there. Here is his statement, and it's a pretty convoluted statement, but the meaning is clear enough. It remains possible that the database is insufficient to compute mean sea level trends with the accuracy necessary to discuss the impact of global warming, as disappointing as this conclusion may be. In other words, if you go to the scientific literature, you'll often see that the authoritative assertions are no more credible than the pathetic picture of the polar bear that accompanied the letter, which was incidentally a Photoshop picture. Okay, getting on to a third matter. Global warming, mentioned the definition. It refers to an obscure statistical quantity and globally average temperature anomaly. Okay. Well, what does this mean? Because we're used to speaking of global mean temperature. But as Chris Essex pointed out years ago, that doesn't mean anything. So what people do is they take each measuring station, and crudely speaking, they take a 30-year base record, get the mean, and look at how it deviates. And that way you can compare different stations. It doesn't matter what their mean temperature is. You want to know how much it's changed. This quantity is actually the small residue of a far larger and mostly uncorrelated set of local anomalies. It's on the order of about 0.7 degrees centigrade over the past 150 years. At this level of a few tenths of a degree, it's always varying. You always have cooling or warming. And it's varying on virtually all time scales that you can resolve in the instrumental record, which is only about 150 years. One of the things to keep in mind, and I know Bill Gray and others have emphasized this, on the time scale of 1 year to 100 years or so, you have no need whatever for external forcing. And that's something I find a lot of people are confused about. They'll say, well, you know, if it wasn't caused by man, what caused it? And that assumes that the Earth as a system, if you didn't force it to do something, would be static. But it is, in fact, a turbulent system that is never in equilibrium. I mean, when you hear somebody say that the Earth is in equilibrium, it has to have the same amount of energy coming in as out, and so on, that's never in effect true, certainly not at the level one's talking about with greenhouse warming due to CO2. I mean, every time the ocean, for instance, takes heat and carries it into the deep ocean where it's isolated from the surface, that's a kind of forcing of the surface climate system. It's even more complicated. That isn't the only source. I mean, when you have transport of heat north-south in the atmosphere, you're transporting heat between regions which have a lot of water vapor and a lot less, and so the system is out of equilibrium for a while and fluctuates. Even with numerical models, if you run them with no forcing and no ocean, they still will fluctuate tenths of a degree. Part of the problem in this field is we're dealing with this anomaly. It's measured in tenths of a degree. We can hardly perceive it. The error bars associated with its determination are so large that it is quite frankly easy to abuse. And again, we'll come back to that. Let's see what it is really. I mean, this was done years ago by a late colleague at Lawrence Livermore Laboratory, Stan Grotch, and he wanted to go over the process. So here you see a cloud of dots. What are they? Well, let's first do the exercise of looking at the axes. So you notice that it's going from -6 to 6 degrees centigrade. That's the scale. The cloud of points is extending over -2 to 2 degrees. Each point is a station's annually averaged anomaly. So that's this huge set of points. To get the globally average temperature anomaly, you average these points, usually with a weighting for area, and on the same scale, on the same scale, that's what you get for the average. You'll notice it's again going this time -4 to 4, but it's roughly, each interval is 2 degrees. Normally, you would compare these two and say that the first cloud was largely random and almost all the variability averaged out. But that would not be an interesting story. So what you do is you stretch the scale on the right by a factor of 10. Okay, and that's what you get. That looks much more familiar. And then we obsess on that as though it was an omen of something. And we argue, where was the rate of change greater and where is the peak? But remember, what we're talking about is that. Now, just to get it into some perspective, this is a kind of diagram. This is a couple of years old already, but it doesn't matter. Every day in the Boston Globe, our local newspaper, there is a diagram like this. And you can see on this there are these blue bars. There is that gray, dark gray band, and then there's a light gray band. What are these? Well, each of them is for one day. You start out the day you're looking at. Let's say this is April 30th, so it's April 29th, and you go back 1 month. Each blue bar is the high and low for the day and a bar connecting them. Each dark gray is the average high and low for that day. And the light gray are the record high and record low for that day. Unfortunately, you only have the years for the record high and record low that were on the day before the newspaper came out. So in this case, the record low was from 1909 and the record high was 1974. Okay, so every day you're seeing excursions on the order of 10, 15 degrees centigrade, or roughly 1.8 that Fahrenheit. And then you have that red bar in the middle. And what that is a line whose thickness represents the range of global mean temperature anomaly over the past century. So it's that we're obsessing on, just to put it into perspective. Okay, continuing with these issues, the claims that the Earth has been warming and that man's activities have contributed to warming happen to be trivially true and essentially meaningless in terms of alarm. These are important to keep in mind. The things that might be relevant to alarm, and I say might be, are the magnitude of the warming we expect and the relation of warming of any magnitude to projected catastrophe. Now, when it comes to unusual climate events, which always occur someplace, you're going to have a drought, you're going to have this, that, the other thing, major snowstorms, hurricanes. Hurricanes will be more numerous one decade than another decade. But when you relate them to global warming, you're almost always guilty of what's called the prosecutor's fallacy. This is, in its simple terms, a statement that if A shoots B, A will certainly have gunpowder on his hand. However, if C has gunpowder on his hand, you cannot assume he killed A, shot B. Indeed, if you saw somebody who had gunpowder in his hand in a distant city, the odds would be 0. Now, with global warming, one has carried this to an extreme. It's sort of like, and I've given this example before, but if A kicked up some dirt, he left an indentation in the ground, a rock fell into this indentation, B tripped on the rock, bumped into C, who was carrying a carton of eggs, which then fell and broke, that it would show that if you found some broken eggs, it showed that A had kicked up some dirt. And we've gone a step further than that. We have said that the best way to prevent broken eggs is to ban dirt kicking. Now, going to some problems, current problems with science. Steve McIntyre and Pat Michaels have described the problems of questionable data. ClimateGate and the involvement of all 3 centers tracking global average temperature anomaly. And I would mention that 3 of them were involved in the emails. There was GISS, there was CRU, and there was the National Climate Data Center of the US in Asheville. Tommy Carl, who's now head of our climate program. All were involved. But this is, I believe, and I think I agree with Steve McIntyre, it's a complicated ethical issue for a number of reasons. First of all, as we've already noted, small temperature changes are not abnormal. And even the claimed changes in the data sets presented are consistent with low climate sensitivity, even if you accepted them. Where the problem arises is in public perception. The public has often been misled to believe that whether it is simply warming or cooling is the issue. Cooling is good, warming is bad, doesn't matter how little. And thus, tilting the record slightly, while it might be of no consequence to the science, could be of great importance to public perception. And this is where I think the ethical issue lies. Now, another more subtle issue in science is that you have more sophisticated data, and one refers to the analysis of this data as validation of models, not testing. In other words, the aim of the data analysis is to support rather than test models. And this certainly has been my experience. James mentioned, I'd served on the IPCC and the National Climate Assessment Program and all these things. And it was evident in that. That's how the programs were described. It also occurred with the recent stuff with the Himalayan glaciers. In any event, third point is sensitivity, and this has already been mentioned by Pat Michaels, is a crucial issue. And this refers to the quantitative issue. How much warming does one expect from a given change in CO2, usually a doubling? Now, I'd add, and this is something that Denning spoke about earlier in one of the sessions. In contrast to what he says, it cannot be determined by assuming that one knows the cause of the change. This is what happens when you use paleoclimate data to evaluate sensitivity. You have to assume what is the cause. If you assume incorrectly, and I would argue it's incorrect in that case, then it could yield infinite sensitivity. I mean, let's say climate changes, CO2 didn't change. You assume climate change is due to CO2. If it changed with no change in CO2, it's infinitely sensitive. This is nonsense. And yet, this infects almost all attempts to infer climate sensitivity from paleoclimate data. Models cannot be tested by comparing models with models. And yet, we have, part of the American contribution to the IPCC program are two programs at Lawrence Livermore Laboratory, and they're legitimate in some sense. One is the atmospheric model into comparison program, and one is the coupled model into comparison program. And it probably pays to compare models and see which one is doing what, and maybe even determining why. But there is a tendency in this process to have assumed that when all models agree, that must be correct. And models are simply not basic physics. Now, despite all this, these are all central to the IPCC reports. And what is worse than that, not only does this make them authoritative, but actually the conclusions, that you arrive at, that the IPCC endorses, have been endorsed by the national academies and numerous professional societies. We saw that in that letter. This is another letter that I think is worth looking at in that context. This is a letter that was signed by the presidents of both the Royal Society and the National Academy of Science, Ralph Cicerone and Martin Rees, and it was sent to Financial Times. I think it tells us a lot about the current state of science. Obviously, again, you can't read this. I'll pick out a few sentences. Here's the first one. However, as your editorial acknowledges, neither recent controversies nor the recent cold weather negate the consensus among scientists. Something unprecedented is now happening. The concentration of carbon dioxide in the atmosphere is rising, and climate change is occurring, both due to human actions. Now let's think about what this says. On the face of it, it could be interpreted as saying that the IPCC statement is too conservative. I mean, it claimed that only more than half the temperature change over the preceding 50 years could be attributed to man's emissions, with aerosols included in what are man's emissions in order to cancel much of the excess warming that the models produce. Moreover, the IPCC attribution, I haven't gone through that, depends crucially on the assumption that the models adequately dealt with all other possible sources of climate change. And by now, the hiatus in warming shows that that's untrue. So the basis is gone, and yet you have this statement. Of course, if you were to carefully parse this statement, you might conclude perhaps they meant that there was increasing CO2 due to man, and there's large-scale agreement on that, and that there was warming due to this, though it might only be a small part of the already small observed warming. If that's what they meant, the statement is again trivial and suggests no basis for alarm. However, I have not the least doubt that this is not what they intended the reader to infer. And this is another problem with the science today. Now then they continue, uncertainties in the future rate of this rise, stemming largely from the feedback effects on water vapor and clouds, are topics of current research. Now, that's on a statement. But who would guess from this? It was a throwaway statement at the end of a paragraph that the feedbacks are the crucial issue. That without these strong positive feedbacks, there would be no cause for alarm, no need for action. What Rees and Cicerone are actually saying is, we don't know if there's a problem. And then we come to a third statement, with which they conclude their letter. Our academies will provide the scientific backdrop for the political and business leaders who must create effective policies to steer the world toward a low-carbon economy. Now, what they're saying is, regardless of the evidence, which they say is not there, it's being researched, the answer is predetermined. If the government wants carbon control, that is the answer that the academies will provide. Nothing could better epitomize the notion of science in the service of politics, something that unfortunately has characterized so-called climate science. So where do we go from here? Well, Pat Michaels was suggesting maybe there could be a different journal and so on. I'm skeptical about that, whether that would help. I mean, this has become a quasi-religious issue, and it's always hard to tell what you do with that. I can speak to what my hope is, that we would return to normative science and try to understand how the climate actually behaves. Certainly our present approach is not a very good one. Now, what I mean by that is the following. It's currently popular, and it's been true in a number of talks at this meeting, that many of us look at dealing with climate by assuming climate is represented by a single number, this globally average temperature anomaly, And this single number is forced by another single number, atmospheric CO2 levels, or for that matter, solar sunspot number. All of these are extraordinarily naive approaches to a complex system, and relying on them limits our ability to understand climate. Now, I don't want to suggest that there's been no progress. There has actually been progress, and some of it is quite remarkable. For instance, I don't know how many of you are familiar with something called the Milankovitch hypothesis. In the 1930s, a Serbian scientist put forward the suggestion that the cycles of ice ages were due to orbital variations of the Earth. And later on, in a program called CLIMAP, where people were obtaining records of the last ice age, and then the Vostok ice core was Fourier decomposed and so on, looked at, people attempted to see if the orbital parameters correlated well with the variations in temperature and CO2 and so on, ice volume. The truth is, the agreement was not great. And then a couple of years ago, a young scientist at the University of Washington made the obvious statement, and never underestimate the importance of obvious statements that have been ignored. He asked the question, he said, look, if orbits are forcing this, why are you comparing the forcing with temperature? Why aren't you asking whether you can compare forcing with the time rate of change of temperature? That's the way it normally works. And he said, let's do that. The correlation turns out to be beautiful. And so we have excellent support for the Milankovitch hypothesis. Nowhere in this was it necessary to invoke CO2. The paper is interesting on this count. It says, I have not mentioned CO2 in this. I do not wish this to mean that I assume that it plays no role. But it played no role in his discussion. It's been other things, too. I mean, we have a recent paper on the early faint sun paradox. And then again, you have to understand, doubling CO2 is a 2% change in the radiative budget. 2.5 billion years ago, before we had oxygen, but we did have water, we had oceans, we had that, solar physicists pretty much are sure that the brightness of the sun had to be about 20%, maybe even 30% less than it is today. Carl Sagan was the first person to popularize this question, and it was called the early faint sun paradox. And for 30 years, there have been attempts to account for it with greenhouse gases. Turns out if you want CO2, you need 3 atmospheres of it. And the geologist immediately can look at the paleosols and records of that time and say, that's impossible. And it went on. Methane was tried. It had the wrong spectrum. Ammonia had the wrong lifetime. What we show is that thin cirrus clouds with today's properties could pretty much get you out of the paradox with less than 100% coverage in the tropics alone. It's not saying that this is the answer, but it says it's not hard to find something that could have made up for it, but it can only make up for it if these clouds act as a negative feedback. If they were a positive feedback, you could not resolve the paradox. Now, that brings one into the science, and I don't know how much time I have left. I'll spend a few minutes just sketching out some of it. One point I'd like to make is how current approaches inhibit progress. You've all seen this stuff with the northern hemisphere sea ice area, and how it's varied and how it's basically recovered from 2007 by now, and how in the southern hemisphere the sea ice is not decreasing. A big deal is made that, it may be increasing, but I think you'd have to admit there's nothing dramatic going on in this picture. But what was dramatic, I found, was the temperature in the Arctic. And the Danes keep close track of that. And I can't read this well enough. I don't have the eyesight. But these are several years' records, different years, and I have 8 of these because it's the same for each year, and their records since 1960. What you see is the variation of temperature with day of year. And so in the middle you have summer, and at the perimeters you have winter. What you see in this is summer temperatures have not changed in the course of the record. And that's interesting because you have all this thing about summer ice and so on. On the other hand, in winter we see immense fluctuations. Again, the scale is, tens of degrees. And, I haven't cherry-picked this. This is, 1960, 1970, 1980, 1990. Same story. They are the same features over the life of the record. What's going on in this picture? Well, what it's showing is that during summers, when there is sunlight, the temperatures are largely determined by local radiative balance, and this doesn't seem to have been changing. During the winter night, the temperatures actually would have been much colder than was shown if there had not been heat transported from low latitudes to high latitudes. But it's transported by turbulent eddies, cyclones, storms, whatever you want to call them. And understanding Arctic temperatures has to involve understanding why these storms erratically penetrate to the Arctic. Judging from the temperature, CO2 is not a major player. Just for the record, summer ice depends mostly on how much is blown out of the Arctic basin. The temperature was not a big factor, clearly from the temperature measurements. And this itself is not novel. It's textbook information. It's also part of Inuit folklore. They have several words for the winds that do this. You've already seen this thing many times. It's funny. It's the role of anecdotes, that can be much more dramatic. The Arctic Ocean is warming up. Icebergs are growing scarcer. In some places, the seals are finding the water too hot. Reports all point to a radical change in climate conditions and hitherto unheard of temperatures in the Arctic zone. Expeditions report that scarcely any ice has been met with as far north as 81 degrees 29 minutes. Great masses of ice have been replaced by moraines of earth and stones, while at many points well-known glaciers have entirely disappeared. And, this is the U.S. Weather Bureau, 1922. In fact, the Arctic is notoriously variable. Similar statements are available for 1957. The skate surfaced at the North Pole in 59. So much for unprecedented. Now, the other point I'd like to discuss briefly is it's essential to know climate sensitivity. Model predictions do depend on positive feedbacks, not just the modest effect of CO2. What one means by that, and this schematic is probably the most important thing for you to try and understand, if you start out with an atmosphere in equilibrium, which may never exist, but let's assume you start with that, then you have net incoming solar radiation, which is, say, the incoming solar radiation minus the part that's been reflected back. And you have outgoing heat radiation, and they're in balance. If you then, in the second panel, add some greenhouse gas, suddenly, it will inhibit the radiation of heat radiation, or generally inhibit outgoing radiation. And so the system is no longer in balance. It tries to restore balance by warming. In the course of warming, if you have feedbacks, if the feedback is positive, it will add more water vapor or clouds or whatever you need, and it will further reduce the outgoing radiation, forcing you to get still warmer in order to equilibrate. So the test you want is for fluctuations in surface temperature. You want to be able to compare what's observed in the change in outgoing radiation with what the models say you should see. And for some years now, I keep forgetting which button to push. Okay, there have been two satellite systems, ERBI, Earth Radiation Balance Experiment, and the Clouds and Earth Radiation something satellite series, that have been measuring both the visible and infrared outgoing radiation. Now, this is an equation concerning feedbacks. It says that delta T will be the delta T, the 1 degree without feedbacks, divided by 1 minus F. Come back to why I show that, but delta T 0 is this 1 degree. And the idea was to look at the satellites and see what you get. And what you ended up getting from them was essentially a negative feedback. F is about minus 0.6 when you include both shortwave and long wave, with a certain uncertainty. The uncertainty is not simply the sum of the two, because in fact the long wave and short wave are not decorrelated. Now, when you do the same thing with the models, it happens that the AMIP program forces the models with the same temperature that was observed for the data. And there, what you get is always positive feedbacks. It means that in the models, you always got less outgoing radiation than you'd get without feedbacks. In the data, you always got more. Now, in terms of the temperature, you could compare the feedbacks that you estimated from the models with what is claimed to be the sensitivity of the models. As Pat Michaels pointed out, this is not that carefully determined. You have the second and third columns comparing it. Doesn't look that great, but if you then took the standard errors and looked for the 90% confidence intervals, which would be twice the standard error, or the 95%, 3 times the standard error, then you find out that the model outgoing radiation is actually consistent with a huge range of sensitivities, often going to infinity. There is no such uncertainty with the observations. When you look at the 95% confidence intervals, that's a sensitivity of 0.5 to 1.2. Why is that? It's this formula again. When you have a positive feedback, you're getting close to the denominator being 0. When you have a negative feedback, you're in a range where it depends very slowly on F. So, for instance, if you look at this diagram here, the pink or violet or whatever color you'll call that represents the uncertainty in the model sensitivity. And you notice that the small changes are in the vertical part of the curve, so it gives you a huge uncertainty, whereas the uncertainty for the observations is in the horizontal part of the curve, and it gives you a fairly well-determined sensitivity. In any event, that's all I'm discussing here. Let's end it here. We can discuss the science more if there's any Q&A, but the work on the early faint sun pretty much confirms that we should have a negative feedback. This gives you some idea of why I think there won't be much warming due to CO2. And without significant warming, it's impossible to tie catastrophe such warming. But I'd add the point, even with significant warming, it's pretty hard to attach catastrophe to warming. One suggestion I'd make is that we stop accepting the term skeptic. As far as I can tell, skepticism involves doubts about a plausible proposition. I think current global warming alarm does not represent a plausible proposition. And, 20 years, more than 20 years, unfortunately, 22 by now since '88, of repetition and escalation of claims does not make it more plausible. Quite the contrary, I would suggest. The failure to improve the case over 20 years makes the case even less plausible, as does the evidence from ClimateGate and other instances of what are essentially overt cheating. In the meantime, while I avoid making forecasts for tenths of a degree change in globally average temperature anomaly, I'm quite willing to state that unprecedented climate catastrophes are not on the horizon, though in several thousand years we may return to an ice age. Thank you.
Very well.